Well, hello and welcome. We're going to look over the most difficult, or well, seemingly the most difficult topics on probability for Khan Academy. The topics include dependent probability, multiplying dependent probabilities, calculating conditional probabilities, and dependent and independent events. So we're going to be looking at these four. So the first one, dependent probability. This is just the idea that the chance of one thing happening is reliant on something else happening or not. And so I'm going to read through this and kind of describe what that means. So in this scenario here, we have two ships. There's Captain Emily has a ship, the HMS Crimson Lynx. The ship is 4 furlongs from the dread pirate Ashley and her merciless band of thieves. Okay, so it's kind of a little scenario here. Someone got playful with the language. If her ship hasn't already been hit, so this is the condition, right? If her ship has not already been hit, Captain Emily has a probability of 1/2 of hitting the pirate ship. And then if her ship has been hit, she always misses. So this kind of simplifies things a little bit. This kind of makes it very cut and dry. And so this is dependent, right? Her ability to hit the pirate ship is dependent on whether or not she's been hit. If she's been hit, then she's done. And then in the same way, if her ship hasn't, if Pirate Ashley's ship has not been hit, the probability of her hitting is 1/6 to the captain's. If her ship has been hit, she'll always miss. So it's the same kind of thing, right? So she has the same kind of condition. She's also dependent. So whoever can shoot first has a much better chance because they can have their probability without the other. So let's see. It says, here's the actual scenario. So if the captain and the pirate each shoot once, and the captain shoots first, what is the probability that the captain hits a pirate ship, but the pirate misses? So in this situation, they want to know what they're really asking is what is the probability that the captain hits the pirate ship, and the captain gets the first shot. So what that means is the captain's shot is not. This doesn't play out. She doesn't have. She gets a free shot basically without the chance of being hit. So she doesn't have to worry about the pirate hitting her first. And then it says, but the pirate misses. Well, if Ashley hits, the pirate will miss. It's guaranteed. So that simplifies things too. So we don't actually have to worry about the probability of the pirate missing because it makes it 100%. Ashley will miss if Emily hits. So what's the probability of Emily hitting? It's 1/2. And that's going to be the answer. 1/2. So this throws off a lot of people. People are trying to multiply or add or do all kinds of weird stuff with these fractions based on previous assignments. But you really have to read what's happening and try to understand what they're describing. So Captain Emily shoots first, and if she hits, Ashley will miss. The pirate will miss. So this is her chance of doing that, making that happen. Now, here's another type of question. So instead of, so I'm going to go through this too because it may not look the same. So this says, if a teacher chooses 2 students, what is the probability that both of them have done their homework? So in a class of 8, there are 3 students who have done their homework. Okay, so if she's going to pick a student, let's just do one student. In a class of 8, 3 have done their homework. What's the probability that one has done their homework? It's going to be 3 out of 8. I apologize for my sloppy writing. So 3 over 8. That's great, but she's going to pick 2 students, right? She chooses 2 students. And so the next one, if she chooses a second student, she's not going to put the same student back. She's picked her first student. And so there's only 2 students left out of a 7 possible remaining students that have done their homework. And so if she's going to pick 2 of these in a row, that's an AND probability. An AND probability, so 3/8 and 2/7, that's multiplication. So I'm going to draw a little multiplication dot there. So this becomes, these twos can, this 2 can reduce this 8. And 8's really just 3 2's being multiplied. So this 2 can cross out with one of these 2's. And then we have a 4 left. 4 times 7 is 28, so we get 3 over 28. Now, if you're not sure about that math there, you can multiply them together and reduce. I'm not sure if it'll take a fraction or not, but it probably will as long as it's an exact decimal. Or sorry, decimal not. It'll take a fraction. So I hope that makes sense, that when you're doing two things and you multiply, the reason why this is dependent is this first thing has to happen for the second thing to happen. She has to pick a student who has done her homework on the first time and then do it a second time for those things, for both these things to happen. So the second student being picked is dependent on the first one actually happening. And that's why it's a pretty small probability. 3 out of 28 is about 10%, a little bit less, a little bit more than 10%. So all right. So that gets a dependent probability. I'm going to go on to multiplying dependent probabilities. So this is a little more complicated. And we'll get into what this looks like. So this is a sports club that offers students the opportunity to play 5 sports over the course of the school year. And these are the 5 sports: basketball, soccer, football, hockey, or Quidditch, a Harry Potter broom game. Members of the club are allowed to play as many sports as they like. Let Q represent the event that a student in the club plays Quidditch, and H represent the event that they play hockey. Okay. So given a randomly selected student in the club, the probability of Quidditch, probability of Q, is 90%. 0.9 is 90%. The probability they play hockey is, or H, yeah, hockey, is 6%. And the probability they play Quidditch and hockey is 50%. Okay? So I'm going to draw a table. Will they let me draw? Oh, yeah, they will. Okay. So I'm going to draw a table here. Let's see. Maybe. Let's see my freehand mouse skills here. I'm going to make this a grid of 9 by 9. So 3 going across and 3 going vertically. Trying not to be too sloppy. Oh, let's see, there we go. Trying to keep it looking not terrible. Okay, so I'm going to make my columns Quidditch. So this is going to be the probability of Q. Instead of putting P of Q, I'm just going to put Q to simplify my, well, I'll just put P of Q. There, P of Q. And then they could also not play Quidditch, right? So I'm going to put NQ for not Quidditch, or the probability of not playing Quidditch. Okay, and this is going to be the total. And then on the rows here, I'm going to do the hockey. So I'm just going to put probability of hockey, and then we put N and H for not hockey. And then this is going to be another row for totals. So the probability for Quidditch is 0.9. So this is the Quidditch column. So it's going to total to 0.9. And then the hockey row is going to total to 0.6. And everything in probability has to total of 1. So this is going to be 1 here. So this is going to be 0.1, and this is going to be 0.4. So they have the total of 1. You see a dot there, hopefully. Put a 0 in front of it, make it a little easier. Hopes to be a little meticulous in math. It can help make things more clear. So here it says P or Q and H. The probability of Q and H is 0.5. So Q and H is right here where they both happen. So this is going to be 0.5. Where hockey but not Quidditch is 0.1. And then Quidditch but not hockey is 0.4. Because it has to total this way, it has to total that way. And this has to total this way and that way. So this is going to be just 0. There's nobody that does neither. Which is interesting. It's interesting to see, right? There's nobody that does neither. Okay. Now that we have this table kind of formed, this is kind of important to see what's going on. At least in my opinion. I think if you go through the hints, it might show the mathematical way to solve this, but this is kind of a probability table or frequency table, and it will really help paint a picture. So they want to say, based on this information, what is the probability of Q given H? So given H is a condition. So we're only going to be looking at H. We're only going to be looking at this column. Or sorry, this row. So it's Q given H. The probability that a randomly selected student in the club plays Quidditch, so plays Quidditch, given that the boy plays hockey. So it's this given this. So it's going to be 0.05 divided by the total of all the hockey players. That's what's given. So it'd be 5 out of 6. And that's just a fraction. 5 out of 6. Yeah, so that's it. It says you can round in nearest hundredth, so you can make that a decimal. I want to see the hints. Step-by-step solution. Oh, I got to get out of the drawing thing. Okay. How do I do that? How do I... There we go. Okay. So I want to see what they should do. Okay, so they are doing the math behind it. And so there's an equation where A and B is equal to this probability. That's why it's called multiplying conditional probabilities, because here you're multiplying a conditional probability to a regular probability. And so that's where this assignment gets its title. I think it's much more helpful to make the table. So they got 0.83. 5, 6 also works if you just multiply top and the bottom by 10 to get rid of clear the decimals. So yeah, so this is a formula. Probability of Q and H is equal to the probability of Q times the conditional probability of P of H given Q, and P of H times P of Q given H. It's the probability of playing Quidditch given they play hockey. So what they did is they gave us this, and they want us to set it equal to this to solve. But what I did is just said, okay, what's the definition of this? This is the probability of Quidditch given hockey. And I just solved this after we had all the information. If you feel more comfortable solving it mathematically, that's fine. You just have to write this formula down right here and be comfortable with manipulating equations. So I think creating and using the table is a little easier, but if this is easier to follow, then I encourage you to do what you feel most comfortable with. So this one's a little bit easier because it walks you through all the different things. It kind of gives you an idea of what it means, and they give you a chart here so you can see everything. So this is kind of nice, and I'm going to go through it real quick. So I don't need to read this because they're asking many separate questions. We have to get them all right. If we get any one of these wrong, it'll mark it wrong. So the probability of A is just the probability that the first dice is a 1. Well, if you look at this table, I'm going to call the first dice black. It really doesn't matter which one you call first and second as long as you're consistent. I'm going to call the first dice black, the black one. And so there's 6 of them here out of a total of 36. If you count all these up, 6 times 6 is 36. There's 36 outcomes. 6 of them are the 1s. That's 6 out of 36 or 1 out of 6. And then what is the probability that the sum of the 2 dice is 3? So there's only 2 here that have a sum of 3. This is a 2 and these are 4. So there's only 2 with a sum of 3. So a sum of 3 is going to be 2 out of 36 or 1 out of 18. And now we have a conditional probability. What is the probability that the first dice is a 1 given that the sum of the dice has a 3? So there's only 2 that are 3 and one of them right here is a 1. So given this second part, given that it's a 3, we're only looking at the ones that sum up to 3. So out of the ones that sum up to 3, there's only 2 of them here. One of them has the first dice as a 1. So that's 1/2. Or 1 out of 2. So I hope this makes it clear what's happening with probability. And then what is the probability of B given A? The probability the sum of the dice is 3, given the first dice is 1. So that, again, we're looking here. So these are the first dice as a 1. There's 6 of them here. That's the given. So we're only looking at these. If it tells us this is the given, then all the other ones go away for the moment while we examine this probability. So out of 6, there's 1 that's a 3. So it's 1 out of 6. Out of these 6, this is the only one that adds up to a 3. So what's the probability of A and B? This is just the probability out of everything happening. What's the probability that these both happen? So you can multiply these together. 1, 6. Well, probability of A and B. Maybe not. So A and B is just this one right here. It's where they both occur. Where the 1's first and there's also 3. That's out of 36. So I know that this is 1 out of 36. Because there's only one way for this to happen out of 36 possibilities. And to get that, you could either multiply b times a given b, or a times b given a. So that's that formula that I was talking about earlier. So talking about that, a times b of a, here's b of a. If you multiply these, oh wait, a and a of b. So if you multiply these, you get 1 over 36. And then this one should also match. This should also be 1 out of 36. So if we do our math correct, these last three should always be the same. It should always be the same. A and b is the same as a times b of a and b times a of b. So I think that's all the ones for this one.